Contemplating Finitism. So this particular video / audio recording is inspired by the research of an independent philosopher called Steve Patterson. For a time he was doing a sort of neo-Socratic journey of travelling the world, interviewing various experts in different academic fields and demanding that they defend both their own reputations and that of their field as a whole. Anyhow, I should say about the format. As you can see, I'm present. If you are watching in an visual format, I am in my library where I'm due to do a shift in about 35 minutes. And I am trying to record on an old laptop that I was given for free because I am sick of trying to record on my tablet. The thing's too smart. Anyhow, so Steve Patterson and his neo-Socratic quest. Two big conclusions that he reached, or I should say three. First, every academic field has its own mafia. This being a collection of people who are basically motivated more by job security more than high pay, but job security and being able to say that they're an expert rather than the quest for truth in and of itself. Secondly, he came to the conclusion that mathematics is upstream of most other disciplines, and as such, if the mathematicians make a mistake, it spreads to just about every other department, sometimes directly, such as in the case of physics, and sometimes indirectly, but pretty much everyone uses some statistics or something at some point. And thirdly, he concluded that the revolution in mathematics of about a century and a bit ago, I believe, was won by the wrong faction. So that got me into doing my own little assessment of the alternative approach to mathematics, and this isn't just a branch, but a whole underlying philosophy called Finitism. Now, I should confess at this point that I am a profoundly non-visual thinker and thus not at all well suited to doing maths problems. Even basic arithmetic makes me go cross-eyed. But I am fascinated by the adjacent issues of trying to get definitions right. So, look, I'm just going to say what I understand of the problem so far, and if you watching this are a person who understands maths better than I do, I would be most interested in your feedback. So, as far as I understand it, mainstream contemporary mathematics is based on set theory. Set theory being a mathematical theory of categorization very closely related to logic. In fact, it's difficult to see how they're different in some ways. Basically an algebraic notation for how categories go together. So, in this attempt at using set theory as the foundations of all mathematics, numbers are considered a set, that is to say a category, made up of smaller categories. Obviously, you have your whole positive numbers, 1, 2, 3, 4. You have your negative numbers, -1, -2, -3. And those can be used to make a line that has both away from the origin point, with the origin being 0 in one direction and away from the origin point in the other direction. Then you have your fractions. Half, quarter, an eighth. And the particularly interesting thing is that this approach was this approach assumes that you can have a infinitely large list that is complete, and one subset, I should say, of an even larger, more infinite set. So, for example, between 0 and 1, there are there is an infinity of fractions that are less than 1, but more than 0, and between 1 and 2, there is a further infinity. Therefore, 2 is 2 times infinity, where 1 is also infinity. Look, this is what modern maths is based on. It's considered normal amongst people who have studied this to a high level. Now, the finitists are a rogue faction who say that, in fact, all numbers are whole numbers, and that if you ever think you've found a fraction of less than 1, you have got your base unit wrong. So, in a recent-ish episode of this podcast, Patterson interviewed a programmer friend of his who has become enamored with the same problem. And the two of them agreed that the engineers who lay down the basics of digital computers, without realizing the profundity of what they've done, actually made a fairly comprehensive finitist mathematics in order to get the computers to work, because the basic fact is we can't fit an infinite amount of information into a finitely large computer. So, for example, I am sure that if you're watching me, you are familiar with the idea of a pixel, one dot on a computer screen. According to the finitist mathematicians, there are no circles because everything is made up of points that are of size 1. Therefore, there aren't really any circles. There are different arrangements of, voxels would be the correct term for 3-dimensional points rather than 2-dimensional points, but you get the picture. And if I understand it, in this view, the number pi is actually an approximation of the different ratios that different sized objects have, where these objects are approximately but not truly circular. So, having done some reading of my own on the subject, it has come to my attention that there is no logical proof that either the mainstream mathematicians or the rogue finitist are actually correct. Because what lies between them isn't a matter of mathematical fact as such, but rather a disagreement over what mathematicians are even trying to do. The finitists are really going back to the original Egyptian surveying project, measuring great big ropes across the sands to see how many stone cubes they need for their pyramid, or something to that effect. They are developing techniques for measuring things in real life, where you go in knowing that your measuring instrument only goes down to such a small size. There's also the ultra-finitists who are considered weird by finitist standards. They say that numbers only exist when you think of them. Therefore, there actually will be, in the history of the universe, a largest number, which will exist for precisely as long as someone is using it to count or make a measurement. An interesting case to be sure, but yeah, that's considered nutty even for finitist. Now, from what I can tell about the mainstream mathematicians, what they're actually doing is studying how we can construct orderly relationships between purely mental objects. Sorry, there's some children making noises outside. So that is actually a very valid thing to study. That if you put forward that there exists points and dimensions and all that sort of thing, and distance, and you put forward rules that you have invented and that are somewhat arbitrary, but you have the intent of applying them consistently, there appear to be conclusions that you will reach in a manner that can't be avoided. Again, if you're going to be consistent about it. And when you're working in such a fashion, you don't have to limit yourself to the idea that space has a fixed size. I should throw in, while I'm at it, that from what I understand, part of what makes the Austrian economists different from mainstream neoclassicals is that the Austrians have a bit of a finitist element as well in terms of how they think about value indices rather than value functions. The neoclassicals are very data-driven economists. They like to get everything mapped onto a nice curve of value versus, or I should say curve, making different gestures in the air. A curve of value versus price. But in order to get the data to fit the kinds of maths functions that they want, some kind of specialised form of calculus, I can't recall what it's called off the top of my head, they have to assume that all consumers are comparing an infinite number of combinations of infinitely divisible goods. Whereas the Austrians, they keep to a theory that consumers have a thing that they will choose first, a thing that they will choose second, and a thing that they will choose third. You do use statistics to find out what these preferences are, but for example, a couple of weeks ago my parents bought a new puppy, and they had to buy one whole puppy. They could not buy 3/4 of a puppy because then it would be a corpse. Yeah, so like I said, if you know more about maths than I do, I would be interested to hear from you. Ryan McCosgrey, over and out.